Welcome to the deep dive. If you feel like the AI news cycle is just relentlessly fast, well, you're not wrong. Today, we're trying to capture a real-time, sort of high-definition snapshot of this AI infrastructure arms race right now. Because the sources we're looking at, they aren't just about, software tweaks. They are documenting maybe the biggest, most expensive engineering project the business world has ever kicked off.
That's absolutely right. Our mission today is really to cut through some of the hype, the more theoretical stuff about like future impacts, and instead reveal the immediate, tangible reality of it all. We're unpacking these huge investments in compute, new cooling systems, the model competition, and the policy battles that are shaping the global business landscape as we speak.
Yeah, we've synthesized a pretty dense briefing. It covers major moves from basically everyone you'd expect: OpenAI, Microsoft, Google, Meta, Alibaba, NVIDIA. And the thread running through all of it, it's this obsession with compute capacity, how to get it, how to cool it down, and how to actually use it effectively. Okay, so let's start with a number that's just, well, it's almost hard to wrap your head around. $400 billion. dollars. We need to unpack the scale here. The main theme is this race for compute, pure processing power. And OpenAI, working with Oracle and SoftBank, seems to be leading the charge with this massive Stargate expansion.
Yeah, the focus is just pure infrastructure. They're adding 5 new huge AI data centers across the U.S. We're talking Texas, New Mexico, Ohio, my own county too. And this isn't just, a couple of new server racks. This is industrial scale power we're talking about.
Industrial scale is right. I mean, the capacity tells the story. This expansion alone brings Stargate's total planned capacity up to 7 gigawatts. 7 GW. Just to give you some context for that number, that's enough juice to power over 5 million typical American homes. It's wow. And yes, that $400 billion investment, that's being deployed over the next 3 years to make this happen.
And that kind of aggressive spending, it really reflects the core philosophy of OpenAI's leadership, right? Sam Altman, the CEO, he wrote this post recently detailing the plan. They want to build infrastructure capable of producing 1 gigawatt of new AI capacity every single week. He sees this as tackling the main constraint holding everything back.
Right. His argument is basically that limited compute forces these impossible ethical choices. Like, do you focus the AI on curing cancer or on achieving universal personalized education? But if you build enough infrastructure, enough compute power, then maybe those philosophical dilemmas become, well, engineering problems instead. If you've got the power, you can chase both goals at the same time.
Exactly. They're fundamentally trying to engineer scarcity out of the equation. But, this brings us to something I found really fascinating in the sources, this kind of self-fulfilling investment loop happening between NVIDIA and Oracle.
Ah, yes. This is where the money trail gets a bit circular. We should definitely slow down and trace this for you, the listener. It feels very much like an ecosystem lock-in play.
Okay, so first, you see NVIDIA announcing this huge $100 billion investment into OpenAI, specifically earmarked for infrastructure projects. Okay. Then, almost at the same time, OpenAI signs this massive contract with Oracle, reportedly worth $300 billion for Oracle to provide the cloud computing power for Stargate. But then, and this is the really interesting part, Oracle turns around and strikes a deal with NVIDIA to buy $40 billion worth of NVIDIA's high-performance chips, including their next-gen Vera Rubin platform, to power the very data centers that OpenAI is paying Oracle for.
Wait, hang on. So NVIDIA invests in OpenAI.
Yep.
Who then contracts Oracle,
Right.
who then uses a big chunk of that contract money to buy more chips from NVIDIA.
Precisely. Well, NVIDIA is essentially bankrolling the expansion of demand for its own products. This kind of financial leverage puts NVIDIA in a really powerful position to, let's say, influence OpenAI's future hardware choices. It helps ensure that the custom solutions built for Stargate are, nicely complementary to NVIDIA's tech.
So what does that mean for the rest of the market, for the business landscape? That kind of concentration, that financial entanglement? It sounds like companies outside that NVIDIA ecosystem could face some serious challenges, right? I mean, if the leader in AI models, OpenAI, is basically locked into this strategic deal with the leader in chips, NVIDIA, via Oracle, doesn't that kind of squeeze out smaller chip makers or other cloud providers?
Or absolutely. It creates enormous barriers to entry. This concentration means the hardware designed for future AI, like that Vera Rubin platform they're planning for the first gigawatt deployment in 2026, which is all about massive parallelism, gets optimized around this specific partnership. It sort of bends the whole future of AI infrastructure design around this triumvirate.
Okay, so we've established companies are betting literally hundreds of billions that they need more power. raw compute. But all that power, I mean, it generates an absolutely terrifying amount of heat. And if you can't cool it efficiently, you can't actually run it at full tilt, which makes that $400 billion investment kind of moot.
Cooling is, maybe, the critical engineering bottleneck in this whole race. You can't just keep building bigger and bigger data centers indefinitely if you can't improve the density of the servers inside them. And you can't increase density without solving these thermal challenges, which is exactly why this Microsoft announcement about cooling is so significant.
Right. Microsoft is claiming a major breakthrough. They're using a new microfluidic system for cooling AI chips. How is this really different from, say, traditional liquid cooling methods?
Well, traditional methods often use what they call cold plates that basically sit on top of the chip package. Microsoft's innovation here is bringing the liquid coolant directly to the chip itself. They do this through these incredibly tiny channels, microfluidics, etched right onto the back of the silicon die. So by getting the coolant much, much closer to the actual heat source, they get radically faster heat transfer away from the chip.
That sounds like true integration. The sources even mentioned they used AI to help design the optimal pattern for those little channels, didn't they?
They did, yeah.
So what's the real-world payoff? What does this mean for performance?
Well, the company claims this technique can slash the maximum silicon temperature rise inside a GPU by as much as 65%. Now, that's potentially a huge deal. Why? A couple of reasons. Better cooling means you can potentially overclock the chip safely, push it harder for more speed. And maybe more importantly, for cloud providers like Microsoft, it lets them pack servers much closer together. This significantly boosts the computational density of their data centers and cloud offerings.
Okay, but wait. If Microsoft just figured out how to cut the temperature rise by 65% with this new microfluidics thing, why is OpenAI still pouring $400 billion into these massive, seemingly more traditional data centers with Oracle? Is this Microsoft tech only for their own custom chips? Or maybe it just isn't ready for that massive 7GW scale yet? What's the disconnect?
That's a really good question. It likely comes down to a mix of timing, scale, and proprietary technology. This Microsoft breakthrough is probably positioned right now as a key advantage for their own Azure cloud infrastructure. OpenAI's massive deal with Oracle and NVIDIA needs an immediate, proven solution that can scale up incredibly fast. So, they committed the $400 billion to secure known, reliable power and physical space now, even if that means using perhaps slightly less cutting-edge cooling initially. You could say Microsoft is optimizing for density, while OpenAI is optimizing for sheer volume. Two different strategies, really.
All right, let's shift gears a bit. Moving from the physical infrastructure, the engineering side, to the actual AI models themselves, the software, the algorithms. This is where you really start to see some clear strategic differences emerge, especially globally. While Western labs like OpenAI and Google tend to have these slower, more deliberate, sort of monolithic model releases, Alibaba in China is taking a completely different tack.
Yeah, Alibaba is pursuing this strategy of aggressively, almost flooding the market is the phrase used. We just dropped 6 new specialized variants of their Qwen 3 model family all at once, covering text, vision, audio, safety. And the big headliner is this 1 trillion parameter model, Qwen Max.
1 trillion parameters, okay. The sources say it has near-frontier capability in things like agentic tasks. What does that actually mean for, say, a business user? What can it do?
Well, in practical terms, agentic means the model is really good at acting autonomously. Think complex tasks like writing sophisticated code, managing multi-step processes, or even interacting with other software tools and APIs with pretty minimal human guidance. And they also release Omni, which is key for global reach. It handles text, images, audio, and video inputs, and understands speech in 19 different languages. The whole strategy seems less about having one single giant model and more about providing a whole suite of localized, specialized options right out of the gate, something Western models often lag on.
Okay, so that's the competition heating up. But how do we even measure who's winning? You know, the standard leaderboards everyone quotes, they become a bit, well, maybe too simplistic. Scale AI seems to be challenging that status quo. They're asking a slightly different, maybe better question. Which model do actual users prefer for specific tasks?
Exactly. That's the whole idea behind SEAL Showdown. It's positioned as a direct challenge to dominant platforms like the LMS's chatbot arena or LMArena. What's really different here is how they segment performance. It's not just about abstract technical benchmarks. It's about real user preferences, broken down by detailed demographics, things like age, education level, even primary language.
And they're getting this preference data from a huge global network, right? Something like 100 countries and 70 languages involved.
Which is the critical piece. Standard leaderboards might tell you Model X is technically superior in English according to some metric, but SEAL Showdown aims to give you that much more granular view, like maybe QuenMax actually outperforms GPT-4 for a coding task if the user's working in Mandarin, or maybe another model is preferred for creative writing prompts, but only by users in Spanish-speaking countries. That level of detail is vital if you're making real-world deployment decisions.
Okay, now shifting again policy. Because all this rapid advancement inevitably creates huge regulatory friction. And Meta seems to be signaling their intentions very clearly here, putting serious money behind it.
They've launched something called the American Technology Excellence Project. It's a national super PAC, and they're planning to invest tens of millions of dollars to fight back against what they're calling onerous AI regulations, specifically at the state level.
And the context for that, according to the sources, is pretty stark. Over 1,000 different state-level AI policy proposals have apparently been introduced just this year. That's an incredibly fast legislative reaction to new tech.
It is, and by funding pro-AI candidates from both major political parties, Meta is showing they're serious about this preemptive lobbying effort. The framing is interesting, too. They're casting this fight against regulation as a battle for technology excellence, clearly prioritizing speed and innovation over, perhaps, more cautious legislative approaches.
Meanwhile, Microsoft is tackling a related but different challenge, the content and copyright minefield. Especially given their ongoing legal tussles, like the one with the New York Times, they're developing this pilot program, the Publisher Content Marketplace.
Right, and this system is designed fundamentally differently from, say, OpenAI's approach. Instead of focusing on big, one-off licensing deals to train models, Microsoft's marketplace aims to pay publishers through ongoing transactions based on how their content is actually used by AI products, like Copilot.
Ongoing transactions versus a single lump sum. Why does that distinction matter so much?
Well, it potentially creates a more sustainable long-term relationship. These ongoing micropayments could maybe mitigate future legal risks by setting up a continuous revenue-sharing model. It ensures publishers are compensated as their content continues to be used, evolves, or gets surfaced by new AI features down the line. That seems pretty crucial, especially with that big New York Times copyright lawsuit hanging over them.
Okay, so we've hit the massive capital investment, the critical hardware innovations like cooling, and the battles over models and policy. Let's wrap up by looking at some of the immediate outputs. What are these incredibly powerful models actually creating for people right now? Google seems focused on the creative space with this new app, Mixboard.
Yeah, Mixboard is pretty neat. It lets you create AI-powered mood boards just by typing text prompts. It uses Google's Nano Banana image editing model so you can generate some initial pictures, then literally talk to the AI to ask for specific edits, make that blue, add a cat here, combine different images, and it can even generate text descriptions to go along with the visuals, all in one place.
Nano Banana. That's their more advanced image editing model, right? Designed to be really responsive to those iterative text commands. And the sources mentioned a tutorial aspect too, connecting this to other tools. Like you could use Mixboard and Nano Banana to generate visuals and then potentially use something like Luma Dream Machine to animate them. Creating, say, little animated miniatures for marketing or social media. It shows how quickly these really advanced models are getting packaged into more accessible tools for creators and businesses.
Absolutely. And if we zoom out from consumer apps, the ambition isn't just limited to the US or China. We're seeing a really powerful global push, particularly in the Middle East.
Right. There was the launch of the Middle East's first big AI and robotics lab in Abu Dhabi. That's a collaboration between NVIDIA and the local Technology Innovation Institute, TII.
Yes, and TI isn't just doing abstract research. They're focused on commercial applications too, specifically building generation robots, humanoids, four-legged robots. And they're using NVIDIA's latest silicon, like the Thor system on a chip, which is incredibly powerful. But what's really striking is the wider context here. This is all part of the UAE's publicly stated goal to become the world's first fully AI-native government by 2027.
AI-native government by 2027. Wow. That timeline makes even Meta's super PCM move seem kind of measured. It really highlights how some governments are viewing AI not just as a tool or a product, but as a fundamental pillar of national infrastructure and future policy.
And the sources point out a key connection: training the incredibly complex control systems for those humanoid robots. That requires generating massive amounts of data, often within highly sophisticated simulated environments. And guess what those simulations rely on heavily? The exact kind of high-performance GPUs they're installing in this new lab. So they're building the infrastructure, the research capability, and the national political will all at the same time. It's a very integrated strategy. Hashtag tag outro.
Wow. Okay. So we've covered a lot of ground. Money pouring into compute like never before, critical breakthroughs like microfluidics needed just to make that compute usable, and these simultaneous fights over models, benchmarks, and policy happening across continents. We started by asking, what does the AI business landscape look like right now? So after all that, what's the synthesis? What does it all mean?
Well, the overwhelming impression is an industry operating under this colossal, capital-heavy, build it and they will come philosophy.
Yeah.
It's almost startling. Companies are prioritizing these absolutely massive infrastructure projects literally on the scale of powering small countries, often before having clearly defined, proven revenue streams attached to them. They seem to be making this enormous bet that the applications, the user demand, the actual revenue will inevitably show up later to fill the vast capacity they're building today.
And that really tees up the core attention we found threaded through all the sources we looked at today, doesn't it? You have, on one hand, $400 billion being committed to Stargate alone, chasing that 7-gigawatt target, just immense capital deployment. And yet, on the other hand, our briefing mentioned an MIT report from just August that found something like only 5%, just 5% of corporate AI pilot programs actually managed to achieve rapid revenue growth.
Exactly. And it leaves the central question for you, the listener, the learner, the investor, whoever you are, trying to make sense of this. Is this, we are building compute infrastructure on a national scale right now. Can the innovation, the application adoption, the ability for businesses, creators, scientists to actually find truly valuable, profitable uses for all this power? Can that catch up fast enough to justify these astronomical multi-hundred billion dollar bets being placed today? Or are we essentially building the digital equivalent of pyramids, incredible feats of engineering for a future whose economic reality is still, well, pretty elusive? That huge gap, that tension between the sheer scale of investment and the current proven ROI. That's really what defines the AI business landscape at this exact moment.